next week is the first London event-driven meetup. So this whole thing about event-driven architecture, which I think a lot of you are aware of, it's like Gartner just talked about it as one of the top 10 trends in architecture and technology. So that's a big part of what this is about. One thing that's changed for me personally since the last meetup is I'm now the CEO of a company called EventStore, which is an event stream database built from the ground up for event sourcing technology, originally created by Greg Young, and actually this guy was one of the co-inventors, co-founders of EventStore. So that's one aspect of event-driven architecture as a whole. But this is not about EventStore. This meetup's not about EventStore. It's about event-driven architecture as a whole. So if anybody, we're always looking for people to sponsor, to speak, and get involved in any way. We want to grow the Seattle community. One of my goals, this is part of why I wanted Rob involved, is to have Seattle become one of the leaders. I live in Seattle, and become one of the leaders in this space, in event-driven architecture. And with what we've got from a cloud-based perspective and some of the leadership from Nordstrom and others, it's something I'd really like to grow in the Seattle area.
Yeah, I just want to mention we have a little stamp card, and if you go to the London, Boston, Seattle, you get a free beer. Yeah.
I might actually be able to do that.
It's a little ledger, and you immutably stamp it 4 times.
Exactly.
Geocache.
And we have Chris Condren, who's the CTO of EventStore out here. James is co-founder and chief architect at EventStore. And we have Adam Dimitrick, who's down from Vancouver, who's going to be speaking tonight on event modeling. And Adam's from Adaptec. He's the CEO at Adaptec Group. I use the Adaptec Group. He's going to be speaking on event modeling, this is a preview of a book he's already writing. I think we might even get to see the cover of the book, maybe. We'll see if he actually gets his presentation up and running. So Adam's going to talk about event modeling, and then James is going to speak today about the Raft consensus algorithm and some intersection with events and event-driven architecture. So, all right, welcome. Yeah, let's get started. All right.
Okay, and in the interest of time, I'll shorten my presentation a little bit. So my name is Adam, and I just want to talk a little bit about event-driven as a concept and the fact that as human beings, we are more event-driven than we think. In the software sphere, we've been kind of forced to go down a certain avenue for building information systems because the constraints that were within this world, what we could fit on the silicon chip and what we could fit on magnetic tape and other magnetic media. In the 1950s and 60s, we made a trade-off to get accuracy and get speed because humans were not really good at that. We had manual processes where humans made mistakes, and humans were also, at that point, not very fast at doing those manual tasks. However, we did have very large filing cabinets. But the mistakes and the speed were not something that was a negotiable for business. And so as soon as insurance companies and other larger companies were able to afford computers and the storage, they made the trade-off. In those days, the storage was really expensive, really expensive compared to what a filing cabinet cost. So we were forced to deal with storage that was like this. And when we automated our businesses, we couldn't put what was in the filing cabinets into that space, or at least it was prohibitively expensive. As computing evolved, we had larger and larger amounts of space to use, but the patterns stuck. And what we had was a current state of the system view, and only that. Sure, we added logs, and we certainly looked at backups and maybe log printouts to find mistakes if they happened, but it was after the thought. It was certainly not the way businesses worked beforehand. When you go to your doctor and you have a visit, they don't throw away previous information and replace it with a new report. They add to a stack of all your visits, and there you can recognize patterns if you're getting cancer or something based on what the doctor observed. That's also in accounting, that's done in trading, that's done in a lot of places where we need that ability to go and check as to what happened if there were mistakes or if we need more or different views in the future. That was the way business was done. Computing added this sort of constraint, and I don't think we really realize how much it affected how we build systems today. And this artificial view that we needed to have in order to take advantage of automation stayed with us. It stayed with us in the patterns that RDBMS systems provide. All the good parts of third normal form and being able to store an address only once instead of multiple times, those are concepts that were considered very important in terms of data integrity and started taking on a life of their own in each instance. So the interesting part about that is it's not really natural for a human being. When we discuss building these systems, we're forced to talk about static models if we're looking at how RDBMS systems are built and how we look at state. So what we really need to do is look at how our brains work and how we communicate outside of computer systems, and that's in regular systems. And when we communicate, whether we're selling something or we're talking about what something should do, as human beings, we're naturally gifted at telling stories. In fact, it's how civilization started. And event-driven has this awesome parallelism, is that if we use event-driven approaches, we tap into that innate human capacity to remember better and to communicate better. So how can we use that paradigm if we're going to use events to now build systems? And that's what my talk's about. I wanted to cover this kind of basic high-level look at history that I usually give a longer presentation on, but I just wanted you to sort of know where this kind of thinking suddenly dawned on me as I was introduced to event-driven from a technical perspective, but I see a lot more of a human side to it in terms of specifications and all these other aspects that are very human that really help us into running our systems and running our organizations. So I came up with a concept called event modeling, which is loosely coupled in a few previous works by Greg Young and Alberto Brandolini. So what Greg Young did in 2007, 2008 in Vancouver was really start a process of introducing event sourcing, so getting a stream of events to be the source of truth for a state of a system. That ended up being something that slowly made its way into also articulating the way an entire system would work and how subsystems would communicate within a larger systems. And these got terms like sagas or workflows and other things. So there's a lot of that greater sort of journey mapping, if you will, if you want to use some other concepts from UX or UI and those disciplines. And then later making it less of a whiteboard exercise, but more of a workshop exercise. And that's Alberto Brandolini's contribution to what I came up with in event modeling. And that's using sticky notes and having a very collaborative workshop. So he took that to a very human kind of interaction where you want to have participation from everyone in an organization that represents a number of different roles, if you will, or interests, such as anything from UI and UX to the CEO and the business vision to customer service representatives to salespeople that need to sell the product you're going to build. It really pays to have a common understanding of all those things. So there's this workshop called Event Storming that Alberto does, where people do this discovery workshop in terms of what the problem space is. However, it kind of leaves things like, go ahead and just do some other things like domain-driven design to implement that. And there's really very little guidance into how the solution or a particular try at a solution is going to look at. The difference between Alberto and Greg's approaches on the fundamental level are problem space, solution space. The Greg Young model really looks at exercising a bunch of solution spaces rapidly in order to discover the problem space, whereas Alberto is more about making sure we understand the problem space. And then we're kind of going to focus that as a technical aspect to actually implement. So the reason that I side with Greg's approach is because I find that all information systems really are these systems that have input and output. And if you really dissect what input and output is, it is the CQRS that Greg talks about quite a lot. If you dissect the fact that systems change over time, you notice that there's an event sourcing aspect Now, because going back to what I said about the limited storage before, we throw away the historic events. But that doesn't change the fact that information systems behave this way and have a set of changes that happen over time. So all systems are CKRS, ES, if you want to use those complicated terms. They have input, output, and they have a ledger of what happened. And so why not use that paradigm to talk about them instead of having something else? So after 10 years of doing this, I actually have an opposite view of what I used to have, that it's actually more natural to do it this way. And so hopefully I'll show you how that is. So this is the only thing that you need for any information system. You don't need any fuchsia-colored stickies from Alberto. You don't need any user stories from your UX people. You certainly don't need any number of UML diagrams from activity diagrams. There's a whole lot of things that become redundant because we're going to investigate, sorry. Oh, great. Okay. Yeah, anyway, so let me remember the Homer Simpson dream in one of the episodes. All you need is this device. Let me show you. In this dream, and he wakes up, but he never gets to see the device that is going to make him a millionaire. So yeah, this awesome system, that's all you need. Anyway, for those Simpsons fans, you know the episode. After 10 years, I've distilled it to about 4 patterns for specification, and the format of the workshops and conversations that you need to have and how to collaborate with all those different roles. Because we'll take a look at how these things are exemplified in this simple, what looks like a very simple system. But we'll see that there's some interesting caveats to this, how some of the more complex things that you know from the industry are represented with a few simple 4 sort of common elements that we have on the right side: UI, API, or a job, command, read, model, and event. There's a lot to talk about here. One of the key differences in specifying systems like this is it kind of takes into account of what we took as waterfall and misrepresented what waterfall was anyway, as we talked about earlier today, and swung all the way to being agile because that totally didn't work. But agile is also a very extreme point of view in terms of neglecting system design. And system design is a complex way of saying, how do we organize our information? And information systems aren't very technical, actually. We're not doing anything complex. What we're doing is we're managing information, and we're moving it from left to right, yet we go to computer science classes in university to do that. It doesn't make sense. So there's a lot of overcomplication that has happened, and I believe that if we can find a way to communicate about what we want to do with a system, it's not actually a technical problem, and we can use very simple terms to communicate with that. The other thing that I've found is that for the first time, I actually believe in estimates again. I find that having a good plan and coming up to a blueprint that people can sort of see as the goal of what the system's going to do and how it's going to act, and it's not a technical thing. We know when we're done specific pieces, and we can start with the important ones. And because we have a better plan, we know that when we are done, we are done. And this is kind of the trick that Agile kind of played on us, and I've discovered this many years after, is that the emergent design aspect of test-driven development, for example, is at odds with itself. TDD is supposed to be something that gives you really solid code, right? You're supposed to refactor as you go so that you get all the solid principles in place. One of the solid principles is open-close principle. So how do you do open-close principle when you're forced to refactor the previous features you implemented? Doesn't that kind of strike anyone as odd? And how you can attain those 2 goals at the same time? It's a paradox. And one of the reasons that the estimates are all over the place is because through this refactoring, even good teams noticed that the 5th feature that they implemented was a lot faster to do than the 50th. Simply when you're implementing the 50th feature, you're refactoring quite a bit of logic, right? And that's not a technical concern, really. That's even a business concern, because there you're basically redoing your entire business. And in Agile, we kind of force ourselves to be a little bit blind to the upcoming features in our backlog or what we have, so that we could concentrate on refactoring what we're building and making sure we're building on a solid. Do you guys get what I'm saying? It's kind of like you're trying to build on a solid foundation, but you're really building on sand because you're forcing that refactoring. So for the first time, these vertical sort of slices of this workflow that we can say is our blueprint of our application can be said that they're going to be done and we don't have to refactor them. That's a huge win, because for now, for once, we can actually empirically look at how long things are going to take. And we can take any number of these slices and have them predictably done in a certain amount of time, and especially a certain amount of cost. And that's very powerful, because the industry has given up with that. There's a no estimates movement and all this kind of stuff. And it's really moved information systems and all of the things that are software away from being engineering, when they really came from engineering practices. So this is kind of a shift back to making it more of an engineering thing. Now, you might think it takes a long time to do this. Some of these things take an afternoon to do for a project. It's incredible how fast you can get to replace what with a traditional waterfall, very sort of red tape process would take, many months into, a week or less, which is crazy that it would actually happen. But I've been there years ago, and after trying all these different things over the number of decades, this is the one that kind of got distilled. And while we have other approaches, I find that I can't simplify further than this, but I'm hoping to. We'll see how that's done. So the other thing about fixed cost is that you can farm out the work to who needs to do the work, and you can ask them to take on the risk of not delivering. In other words, you don't get to work on another piece of the system until you have finished, and any bugs that come back, you have to fix. So if you're going to make really crappy work, you don't get to work on future slices, and you don't get to bill for those. And that can be incentivized differently in a regular organization. But I'm looking at subcontracting a lot of the work, and a lot of people, I don't have the time to interview and give them like 3 months to evaluate them. So I need to give them a fair way to contribute and to have that contract to hire to find out if they're good enough, but at the same time pay them for their work. So how is that done honestly, right? This gives you an idea that I can say I can pay $5 or $50 or whatever per slice, and then if they finish 10 of them, they get paid that much. Because during that time, they were also incentivized not to have to come back and fix things if they got bugs. So that's worked really well. So let's dissect what this thing is and how you attempt to use it, because it has a lot of views from different perspectives. Like I said, from sales, from UX, UI people, from designers, from testers, from developers. So one of the first things you'll notice is that we want to innovate, and we want to enable companies to be able to specify what they're dreaming of and test it with the rest of the people in the organization if it makes sense, or if they want to build that, or if they have other things they want to contribute. And so, oh, James, I think I need a power. I think power just died. I'm going to pause the clock.
Yep.
So this is the third and last, I promise, technical difficulty tonight. Where's the plug?
Down there.
Oh, here. I just hope it turns on. So this is the third and last laptop I'm attempting tonight.
It's coming back. I have backlight at least. Come on. Actually, you know what? I'm going to this for a second. Oh, no, it's not.
Anyway, I'll continue talking so that we just don't. While this pops up, So that last diagram, imagine you're still looking at it, is something that was missing from Alberto's approach and Greg's approach, was the idea that you can talk about the UX and the UI parts of a system when you're designing a system. We always concentrated on the state of the system and what events flowed through it, and all those sticky notes that we talked about was concepts and things that we kind of were writing a book about what's going on. Thanks, James. This little part up here, the UI part, was always missing with DDD, with any number of things we had. So I know you can't see it really well. I'm just graying out the rest of the diagram. So as I go left and right on these slides, you'll notice that all that you change is what I want you to concentrate on. And the reason I'm doing this is just to show you that the different perspectives on the same diagram speak to very different concepts that are very important to different groups of people in an organization. And through that, you now don't have a proliferation of documents that certain people have a specialization in, and then you have to wait and throw things over the wall to a different department. We're trying to find a common way to communicate together throughout an organization, no matter what your job is. In this instance, we're using this diagram to communicate with the UX, UI people, the product owners, to describe what it is that we're building. The top part is what was missing, that UI part. What the customer does, what the administrator does. You can divide that into rows. That's your UX. Down below, we have the events, the things that the system remembers. Someone signed up, someone purchased a book, someone added something to their cart. Whatever system we're doing, we can show the narrative, and you notice that this has a very good resemblance to what you see in the movies as a storyboard and storyboarding. You have key frames as to what's happening. So visually you see what's going on. You understand the plot underneath, and you see how everything intertwines. And that makes for a really good platform to communicate all the user experience points. You can include non-technical things as events over here, as someone actually walking into a store, or whatever it is. But you can communicate across what is going on. And give it a separate swim lane if you want, if it's not a technical thing that you're going to implement, or maybe it's something you bought off the shelf that's going to do that for you. That's fine. But you understand what's going on at this point. And notice also how the legend changes as I move from slide to slide, what things are involved. Because we only have those 4 pieces that we're doing. This is, you get 4 Lego blocks.
So, Adam, could you read the box? It's hard to see it because of the...
It's great. It's not meant to be you can read it now. Right? Yeah. Okay. All right. So does everyone see how the innovate portion of starting a project at a company or being a startup, how this can be used to start that? And essentially, that's, usually with event modeling, what you do is you start the brainstorming process and you come up with all of these orange stickies that you brainstorm about. Oh, what else can we do? Can we buy a product? Can we add something to the cart? Do we get a notification, an email? What else happens? We can put all those down as things that happen. And then we put them down on the line, showing them making sense in a specific order. And we can discuss why something can't happen before another thing. And we can discuss that a few previous things must happen before this one's allowed to happen. We can talk about the story, right? From there, we can engage with the UX, UI people to say, can you just quickly take that marker or go on the whiteboard and draw those wireframes of how you think that UI is supposed to look on that app and what they're going to see in that email at this point, right? So we can collaborate together to get the whole picture. Secure. After we're done, this is looking at the end. We look at the very beginning. Let's go at the very end once your system's complete. I can block out everything else and I can look at the paths for all the data. And I can look at where things cross boundaries, where we have credit card data coming into the system, where it's getting stored, where it's living, where it's getting pulled out. We can see all those pathways. And this is something that a security person would love in any other architectural diagram. And they have to tease it out of most organizations. They have to have interviews with this department, and this team, and that team. And this team had their documentation done this way, and that team had it done that way. So when you have a complete picture of where information flows to on a timeline, so they can say when it happened, your security audit is easy, or at least an order of magnitude easier. So a company that I work with, they can do the regular job in a fifth the time and they still charge the same amount because the product from their security audit is superior to any others. So it's a triple win, right? Which is pretty good. So back to actually building the system. So the meat of it is the middle, is building it. And every information system, or every system in fact, has two things. And this is the input-output, CQRS, read command side, but also it can be divided into things about what you do for a user. And one of them is you empower the user. That means when I change the state of the system, I know that when I arrive at the hotel in 2 months, I'm going to have a place to sleep. So I've been empowered to change the system to benefit me, right? And we do that by allowing a command to be accepted. We say, book that room. And that room booking is just an event. Room booked with all the particulars about that particular event. And that's it. We can specify it by giving a regular given when then, or arranged act assert, or if you're from the UX, UI perspective, if you're a designer, you're probably looking at the same parallel, and I just can't believe this hasn't been really made more obvious. Situation, motivation, and value. Has anyone heard of that from, I think Chris has probably he's here from Vancouver from Plenty of Fish. Really the largest dating site, and they have a really awesome UX, UI department. And they're, as any other organization, sitting in a separate place, not playing with everyone else to do that. And that's not their fault. It's just that we haven't realized these common ways of interacting, like having this common place to interact with those people. And so we have highlighted here the command. And this is what James was talking about. It's like, okay, great. Well, how does Plenty of Fish make sure that we can make a command work across 7 million, concurrent online users? James told you how that's done. But from the business perspective and from everyone else, we still need to know that we're doing this and we're changing the system, and that we can specify whether that command succeeds or not. And that's how we do it. The other part that's quite important here is that for the UX UI person, is it shows that we don't have just a very simplistic way of saying, I'm going to show a form, I'm going to have them fill that out, they're going to hit a button, and that's just going to save it to a table, right? That's how most applications are built. What we're going to do instead is going to say that hitting this button sends a command that I can either accept or reject entirely. I can have a transaction there, and that's an important concept, not technically, but also from a business perspective, both sides, right? This is where we're marrying those two sides quite well. And what that drives from a UI perspective is a command-based UI, which is at the heart of what every designer wants in their web applications, is the ability to have componentized pieces that act with the system in a predictable way so that they can piece together what things are supposed to be behaving like and looking like. And that's a huge... Let me just speed it up because I think... oh, this slept. Yeah. I don't know how far we're at 8:30. How much time do we have? 10 minutes, okay. So the other side is inform. So the same diagram, but we're looking at the green box. That's a read model. And that's a projection of what we have stored in the system already on this ever-growing ledger of fact. We can use that for a number of different purposes. And one of the key things that separates this approach from how we've treated data before is that we're not afraid to make many of these. We can make a view that works for accounting. We can make a view that works for current online, I don't know, shopping cart contents, whatever it is. We don't need to go to a single model. We can interpret the data as we like, and more importantly, as we learn more about our business, adapt those things as well. So there's a whole section on how we move this in an agile way forward as we discover more about our business and what we need to do. So create your own reality as long as it's based on facts. And we already agree that we already agreed how those facts are getting in there. Next things that we need to do is we need to understand. And that means we cannot have anything on this system that somebody doesn't understand in the organization. So whether you're a UI person, whether you're a CEO, whether you're a programmer, customer service rep, you must understand everything. And sometimes we understand them, but they're not really things that are useful. For example, we're working on an app for replacing Uber. And some of the external events we had to take in were coordinates, longitude, latitude. How do you think that would be for specifying whether you can pick someone up at an airport? Right? That would be pretty crappy. You'd have to commit the coordinates of where the airport is and triangulate where, you know, do all the calculations to see if the taxi's within distance to pick that person up. So the translation there was simply, as these different coordinates were coming in from a car driving, is you translate them: entered airport zone, exited airport zone, entered downtown zone, exited downtown zone. Now those terms we can use within the business to specify the software, to specify the system itself. It doesn't matter that it's longitude and latitude. We can understand that, but we've adopted something better that we can understand. Integration is really just done by to-do lists. If I want to send an email to someone, I really have a robot there that's going to be looking at a batch job of where I have to send emails. And when that robot is doing each one, it's going to check them off as done. Of course, implementation may vary, and you obviously may do more reactive patterns to do that. But in order to communicate what's going on, leave it at that. It's a to-do list. It's getting done by something. And when it's done correctly or incorrectly, it gives the resultant event. And you store that as what got captured after that. And that feeds back to the way that diagram works. And I think I'll end it on that. There's a lot more to this. But I haven't seen a single collaborative document yield so much value to so many people from so many disciplines ever. So, any questions?
Can we get on a beta?
Sorry?
Can we get on a review list?
Sure, yeah.
Question for you. When you showed commands and you talked about the transactional aspect, would you envision like a write-through transactional database managing that, or is that just kind of an arbitrary subsystem that handles the transaction, or are you envisioning that transactions are handled on the ledger itself?
It really doesn't matter. I see a lot of this as being 4 simple methods that you implement in any way you choose. Some of them you'll see as hydrate for getting state, and that's another way of doing a projection off of past events to get something like a read model that's specific for being able to handle the next command. There's the read models that handle an event, that give, as events come in, all those green boxes, they're live reports, essentially. So as new things happen, they get updated, and you have the current view that you want to see updated in real time as things are happening. There's 2 more, but it really goes down the rabbit hole of CQRS and event sourcing. There's publish and subscribe, and that's pretty much it. But it's about, if you're talking about handling the transaction and then storing it somewhere, it's really up to you. So I mean, that ledger of events at the bottom could be one table in a database in Postgres that has 3 columns, one for indexing or something, but you're getting something that's ordered. And that's really important, because if you can't guarantee order, you can't rely on that as something that you can specify and predict how the system will work. So ordering is very important in that aspect. So does that sort of touch? Maybe you can repeat your question a little bit more specifically.
You talked about like booking a hotel room.
Yes.
When you're booking a hotel room, you're requiring some form of distributed consensus to say this particular individual gets this particular room while other individuals are trying to get at that room. So you could do that by saying that little blue box represents a transactional database, and I try to make an update to that transactional database. If I'm successful, then I produce an event off the ledger. And that would be kind of front-loading the transactional burden into a more traditional mutable database. The other way would be to say, I'm going to put my claim to that room on the ledger.
Mm-hmm.
You're going to put your claim to that room on the ledger, but because my claim arrived there first, I get the room.
Yeah.
Now I'm doing the transactions on the ledger itself.
So that's, I mean, you can contrast 2 systems. One that's a little bit not as important to do as a ticketing system for concert tickets, right? I use that example. So you definitely have this reservation system where you have to really be explicit about when someone is online, when they say they're interested in something, they have a window within which that is locked, and you could have warmed up 10 servers that have specific allotments of tickets and all that. So that's where that business will probably be expanded on that diagram to be quite thorough in terms of what happens. In terms of something like a hotel booking, you can usually just go ahead and look at the previous events and say that, is the count now 0 for availability of that type of room? Then give it a synchronous error and exit and say, sorry, no more rooms. Otherwise, just put something else on the ledger. And how you do that is you have streams, for example, in Event Store, what James wrote. You're able to look at not just one giant long stream of events, but you can see finite small event streams that could be correlated with something like a room type for a particular season in a hotel. And then you can see the state of that particular inventory type in the hotel by just replaying or looking at, inspecting those events and seeing whether you're over or under, or if you're allowed. And the simple action is just store one saying, yes, if I was allowed to book a hotel, that particular inventory, then I do nothing else but put another event on that ledger that does that. The next person that comes in is going to get the error because it's just run out. That's what I would do. Now the implementation, maybe you can talk a little bit more to the same question from...
Yeah, so constant tickets is a much better example of this.
Yeah.
Actually, hotels don't do that.
Yeah.
So hotels overbook. They account for people who don't show up. They take into account like a loyalty program membership when you check in. So it's not like there's like a finite reservation system. Like if you stay in a lot of hotels, it's not common to get booked. But if you don't, it is pretty common that you'll show up at a hotel and they'll say, actually, we don't have a room for you because we overbooked, and everybody showed up. Like we're going to take you to this hotel instead. Like reservations is one of those patterns where it's a whole domain model in and of itself.
Yeah. Same with flights, right?
Flights are
Yeah.
crazy.
Yeah, yeah.
There's a big movie about how flight booking works from IATA, and then subsequently got bought by Google, and it's worth reading because it's an NP hard problem. Like just to work out a price from like Austin to Seattle is literally an NP hard problem. And, out of interest, does anybody know? You know when you book a flight and you get the 6-letter code back, like the record locator. Does anybody know what that is? No? You must. No?
It's a slug?
Nope.
I forget what it is. I don't
It's a base 36, I guess, encoded memory address into a mainframe.
So yeah, the implementation's a detail. just show that diagram. Yeah, let's do 2 more questions, I guess. Yeah, sure.
We can go to the pub for we do have some time.
Oh, okay. So we can do another 10 questions if they're short. If they're short.
So one of the things I was wondering is, do you have in mind, like with Alberto has this sort of workshop model. So do you have that in mind for event modeling too?
It's run exactly the same way.
It's run as a workshop.
It's run exactly the same way, except that the artifacts that you're producing is something that's a workable solution.
So that was my other question. Is it 2 things? So you're going to go to a workshop, so people are going to sit around, you're going to have people from all these different disciplines. You're going to have different colored stickies that kind of match.
Only 3 types of stickies and then white paper for your, or not even anything. It could be just whiteboard drawings for your wireframes. Okay. That's it.
And so you get the commands and the events and the...
Read models. Yes.
And then transformations?
No, those are just patterns of using those. But that's the interesting part, is that as we go on the bottom here, these are just... Those are that's using those particular components to specify them, right?
Those are the things that are
yeah.
in the upper right.
Yeah.
Okay.
So a projection is just a projection, for example, is a given when then, without the when, because there's no command. It's really just given these events, I expect my availability chart or calendar to look like this, and everyone can understand what that is. Yeah.
Can you talk about the y-axis here? So you have two rows of UI. Does that represent 2 different applications?
Yeah. So there's a lot. As I said, I cut this talk short. Let's just work off of the complete diagram. Yeah, the fact that there's multiple rows of the orange means that you can organize subsystems. So that I can have my payment domain at the bottom. I could have my room inventory subsystem in the middle, and I can have my user authentication or whatever else I wanted a third one.
Mobile app.
Yeah,
and the top
but-
UI might be mobile app, and the mid UI
Yeah.
the lower UI might be web app.
Yeah, it could be, yeah, exactly. It's about how do I organize all those facts so that it makes sense. And notice that I didn't throw in any specific words from domain-driven design or any other disciplines so that I don't lose any audience. So I can talk to the CEO, I can talk to non-technical people, UX people can talk to people that are not versed in journey mapping or other specific nomenclature from their expertise. These are information systems. They're really simple. You're moving information from left to right, maybe transforming it a little bit. You're not solving a computer science problem. You're not writing a new algorithm for encryption. You're really just organizing data. And so there is no reason to have special terminology for it. You should be able to communicate those things to everyone. Yes?
The Twitch audience has a question.
Mm-hmm.
Sponge Ruiner says, what's the best way to get started with event modeling?
Event modeling would be simply just to do it there's a number of the book's not out yet, but there's a number of talks out there. So I would basically, you could use Alberto's book, but throw away all the stickies that are of different color than what you see up here, because it does work. The workshop is very similar in terms of how you run it. Things like a fuchsia note for important decisions. There's no reason to have some standard for it and complicate this anymore. You can put a little star or draw something on the whiteboard or do whatever you need to do. Maybe make a note. But what you want is to really have a unobscured picture of what the entire system is going to do from end to end. And so sometimes, when you have versioning with this system, like you want to change the design halfway through because you discovered some stuff, you simply change this and you can hold it up against the old version and see which slices you've introduced. That gives you your change management, the scope of it, how long it's going to take, how much it's going to cost, right? You have all of those predictable things that you expect, like you would if you were building a house and you had a blueprint. So you want that predictability, and I think we should all be striving to make this more of an engineering practice than just throwing things against the wall, as some of people have been doing. Yes?
I'm not sure if it's just your diagram, but I'm looking at the thing on the left, the UI that has a command that's got the orange event under it, and it doesn't seem to relate to the rest of the system. Is that?
Yeah, yes, it should probably somewhere be shown on a screen if it's important. So yeah, it's probably just an incomplete event. Interesting part about, this is kind of like a sample of what it looks like. So yes, generally that's a good question, because when you're doing this event, like you'd be saying, yeah, boss, we're doing this command. You said it's really important, but I don't see it being used anywhere else in the system. I can't draw a line for that email to anything else. Why are we asking for emails? We're kind of unnecessarily scaring people off, and we're not using that information in the system, right? At the end, we have to revisit that. So exactly, and that's one of the purposes of this diagram, is to be able to draw the lines all the way through the system as an example workflow to show where information goes. And so sometimes you might have, the thing that differentiates this from event storming as well is that you don't have any decision points. Everything is linear. So if you want to show 3 different cases of someone failing a login and retrying and then succeeding, someone adding too many things to their cart and then backing out, taking one out, and you put all of those different things in a row, or you do an alternate entire stream, but you want an example. And this goes back to the very beginning of my talk, which means taking advantage of the storytelling aspect of specifications and why it sits in people's heads better. The minute you start putting decision trees into diagrams, you lose understanding. It just becomes too much of a cognitive load to memorize a choose your own adventure book rather than memorizing, what a book was end to end, right? It plays better with our memories, and it's a better communication mechanism. So that's a active thing that I kind of noticed about the, what happens when we try different things, even like mind maps and other ways to really share information. Stories tend to be much better at communicating things. And so we definitely don't want to have anything like, oh, this could fail. Some of the streamlining in event storming is to have one major flow and show alternate flows down below. What we usually do is when we have one particular slice, we want to show where that command might fail and what other scenarios are. We would have a whole bunch of given when thens underneath somewhere. Like even a real-time board, you could have this at the top. Who uses real-time board here? Everyone know what that is? It's like a real-time kind of canvas that's web-based. You can quickly share with people across the world, but it has a way to do sticky notes and color them, and to do wireframes. It has templates for wireframes as well, so you could have the mock-ups of all your screens. You can take a particular workflow, an entire workflow, copy it, put it down below, do a second one. You could do the given when-thens below and draw lines to that you're explaining this one here, and everyone can look at it. What you're after, again, is something that's easily shareable across multiple disciplines within the company with as many people as possible, so you don't have to have the thousands of meetings during the project. Everyone knows what the business goals are, what the business vision is. Everyone knows what the technical strategy, what, you know, these things, these orange events are your transactional boundaries. They answer quite a lot of business and technical questions on what the vision is. So this erases 90% of the meetings that you would ordinarily have. We don't have any stand-ups. We don't have any retrospectives. We threw away 99% of the Agile book because it's just easier this way. Okay, I think one more, or we're done. Okay, good. Thanks.